Ever wondered how computers remember things? Well, in Python, we use something called variables to store and manage information. And trust me, understanding this is a game changer. Say we want to store Shelly's name, so we're gonna have it like so, Shelly, and then also her age, we could have it as, and then her height, we could have it as 5'7". So, and all this is stored in variables. Simple, right? Now, if you'd want to go ahead and display Shelly's name, then we're gonna have something like print name, and then use name, the variable. Then now we can go ahead and run that. That will be Python variables .py, and then it's gonna print out Shelly for us, right? And that works for the other variables too. So that'll be the age. We'd need the age, and then the height too. So we could have those there too. So maybe say for kids, you can have age, and then let's change this, have it as height, and then now, if you go ahead and run this, we're gonna have Shelly, Shelly's name, age, and height display as such. Now, the other thing that you'd notice is with the assignment. If you're sending a value to a variable, that is name. The name will be our variable name, right? So we're gonna consider this as a variable name. And then we have the assignment operator. So you're gonna talk about that as assignment operator. Let's have it as short op, and then you're gonna have the value that you're considering. So this should look something like this, right? And then Kelly, in this case, will be our value. Now, at the same time, we'll be considering that for all these other values that you have. So you have the variable name, the assignment operator, and the value that you want to consider. And in such a case, then you notice that for case what you're looking at the cosine as the assignment operator, and then you have the variable name as the name that you'll be using to create your variable. Now, you want to think of a variable like a label box where you can keep your stuff. For case, we're going to label or a box, in this case, name. And then you can keep your stuff. For case, you can say, you can have Shelly, like so. And then that means that you give it the specific name that you'd like, and then put something inside it. And boom, you can use it whenever you need it. At the same time, you want to consider the naming rules for variables. So, and these naming rules will be something like you can only start with a letter or an underscore, not a number. So that will be one number. So that means that you wouldn't have something like 78 and then name. You're gonna get an error right away. So you can have such to represent to when creating a variable. So that's one of the rules. The other rule will be when you're using letters, numbers, or underscores, then there shouldn't be any spaces. So that means that you wouldn't have, say, no spaces. Let's have no spaces while writing your variable name. Right? So that's something to consider too. So that means that, so for instance, if you have name, say name, or maybe say you can't have past, then space, name, and then something like that. Jelly. Oh, you're gonna have errors. Okay. At the same time, remember, you want to start with a letter or an underscore, not a number, but you can have a number after the first letter is the only one constricted to a letter or an underscore. But after maybe say we'll say name underscore one, right? Then that should work fine. You can just go ahead and say something like that. You can say Shelly, and then that should work fine. So also note that you can start with the number like so, as we mentioned. So you can have 68 and then something like 78 or something. But what you can do is you can have a number after that. You can say maybe age 1, and then 78. So keep note of that. Now you wanna be careful with the uppercase and lower cases when creating your variable. So that means that you wanna be concerned with the uppercase and lowercase. Obviously case sensitive in this case. For instance, um, name like so, equals to, and name, maybe name, all caps. So these should be different values. So this time we could have something different. We could have Joshua, like so. Now, when you're considering that, then that means that there's a difference in such a case. So you'd have name like so, then name like so. So if we go ahead and print this out, right? So you just go ahead and say something like, so that will look something like int, and then we're gonna have name, and then let's change this to name. And then this time, get to print this out. So let's comment this. And then now, and run this again. You notice that for the name with the uppercase and then the name with the lowercase, you kind of have that clear differences. Now that you know the basics of variables, let's see how we can use them in real program. Okay, so you've got variables down. Awesome. But what if you want to actually do something with those variables? That's where something like arithmetic operators come in. Simply put, there are symbols that tell Python to perform basic math operations. So let's break down this one by one. The first one would have something like addition that you want to consider. And this should basically be adding numbers together. So that would be an example. Looks something like A, you have 6, and then you have B, maybe 3. And then now for this case, you're gonna print out the addition for the both values. So that will be A plus B, right? Remember? Now, if we have that, so we're gonna run that, and that will be something like Python again, arithmetic, then run that, and then we get 9, right? So that means that it has added both values for us. Okay, so you've got variables down. Awesome. But what if you want to actually do something with those variables? That's where arithmetic operators come. Simply put, they are the symbols that tell Python to perform basic math operations. So we're gonna have arithmetic operators like so. And then now let's break down the arithmetic operators. So one of them will be addition. And in this case, the symbol that we'll be using, that will be the plus sign. And then we'll be adding. That means that obviously we'll be adding numbers together. An example will look something like, say we have variable A equals to 5, and then we have B equals to something like 6. Then we're gonna go ahead and print the addition of both values, and that will be A plus B. And then now wanna get its output, we're gonna have it like so, and get that that's 11. Now we'd have that, and then we're gonna have also say arithmetic operations such as subtraction. So let's consider subtraction here. And for the subtraction, a similar math symbol, that is there'll be negative, and then for this case we are taking number away, right? From another. So that's how we'll be able to consider that. And in this case, that would be something like we could have A equals to maybe 5 again, and then B equals to 6. And then this time, if we print the output, we're going to have A minus B, or B minus A, like so. And then we're going to get its output. We're going to just print out that to be able to get the output. And the output for our case here is 1. Simple, right? Now, the same will follow suit for multiplication. So in multiplication, we'd have the same scenario, but let's look at multiplication. And then obviously you want to note the symbol that we'll be using for this case. There'll be asterisk. And then in this case, what you're doing is you're multiplying numbers together. So that said, if we have the same values that we're considering, A and B, we can go ahead and since we've already initialized them, we can go ahead and print A and then asterisk. That will be asterisk B, and then that should be able to multiply both values for our case, right? So if we run that, that will be 30, right? 5 times 6, and that's the multiplication. Now, there's also division that you don't want to consider. So we can go ahead and have division. So we'd have it like so. And then for symbol for this, that should be forward slash that we'll be considering. And in this case, that means we're dividing one number by another, right? So with this, you just have print, and then if you're considering the same values, we can have B divided by A, right? So that will be 6 divided by 5. And then we're going to go ahead and run that, and then get 1.2, such a case. So with regular division, you'd notice the output that we're getting, it gives us 1.2, including decimals for this case. Now, if we use a different, say, arithmetic operation, that is flow division, this is the flow division, and it will look something like this. So you'd use the double forward slash, and then now this will be mostly rounds down to the nearest whole number. So that's something to consider too. So that would be something like, say, for if we consider the same values, that would be B double forward slash, double forward slash A. Then if we go ahead and run that, then it'd be able to say like, hey, it's going to round to the nearest whole number, that is. So yeah, this flow division. Now there's also modulus. So let's look at modulus in this case. So that will be number 6. That will be modulus that we're considering. And in this case, that will be the symbol, the percentage sign. That will be the symbol for modulus. It finds the remainder after division. So there's something to consider. Now, maybe say if we have print again B and then modulus A, then look something like this. So if you run this, we'd have 1. Because what's going to happen is that if you divide 6 by 5, then you're going to be having a remainder of 1, right? Now, it's going to look something like 6, and then you divide it by 5. So 6 goes into 6, 5 goes into 6 one time, and then you have a remainder of 1. So that will be 1, 1. So this remainder is what we get as the output here. Okay. So that's how it consider the modulus and how to work around it. For the 7th arithmetic operator, we're looking at exponentiation. So for this case, obviously exponents, we're using double asterisks. For exponentiation, you're raising a number to a power, right? So that means that, for instance, if you have print, you can have print B and then exponent A, that will be 6 raised to power 5. So if we look at the output, then we're going to have 7,776 for the output in that case. Now, these are the arithmetic operators that you really need to understand. Now, if we do a recap of this, then we've talked about the addition, whereby just use the plus sign and then you're adding number values. And then subtraction, use the minus sign and then you're subtracting your values. Multiplication, using the asterisk sign for multiplying numbers. And then you have division, / for dividing your values. And then say floor division, double / for dividing your values. And something to note is it rounds down to the nearest whole number. So that's something to note. And modulus, it finds the remainder after the division. And then the exponentiation should be raising our number to a power. Now that you've mastered arithmetic operators, you're one step closer to writing real Python programs. Up next, we'll see how these operators can be combined for even more powerful calculation. Imagine you're organizing your desk. You have books, pens, sticky notes, and maybe even your favorite snack. Each of these items is different, right? Well, in Python, we organize data using different types. That's exactly what we're going to learn in this section. Most importantly, we want to look at what are data types. In Python, data type defines the kind of value a variable can hold. So let's say just this will be a value, a variable can hold. So, and that's how you'd look at it. So this is whether it's a number, text, or even a list of items. Python automatically assigns a data type based on what you store. Now, there are two major categories of data types. First of all, we're looking at primitive data types. And then the second one, we're looking at non-primitive data type. So also the non-primitive data types, you can call them data structures. Also, with the categorization of primitive and non-primitive, you could find others say maybe text when you're reading different texts. You won't have such categorization, but this is just to help simplify kind of and understand the different data types and how to work around them. So that said, let's look at say the primitive data types. And for the primitive data types, the definition for the same is that it holds single values. So that's how we'd look at it. And obviously the examples around this would be something like numbers, and then strings, booleans, and non-data type. So for the numbers, we're gonna expound on this and then talk about the aspect of we have here integers and float that we'll be considering in this case. Now we're gonna see their definitions. This will be clear to us in terms of how they work. Now for the data structures, simply put, you can say they hold multiple values. Now let's dive into the most fundamental data type, that is the primitive one. So we're gonna pick this, have it here. Now with the primitive data types, we've just mentioned that it holds single values. They are the most basic building block of Python programming, and hence that's why we talk about the bit of the single values. And so the single values will be things like numbers, text. So unlike obviously the non-primitive ones that hold multiple pieces of data. Now we're going to explore each data type one at a time. So let's start with the integers. So with the integers, simply put, it's a whole number, no decimals, no fraction. It can be positive, negative, or even 0. And that will look something like, maybe say we have temperature. And then we could have -10 for temperature. And then people count. So remember, we're having a variable people count, and then we can have maybe 150,000, like so. So here we have -10 and 150,000 are all integers. They are perfect for counting things, working with indexes, and performing calculations. So those are integers. Also, fun fact, Python doesn't have a limit on how big an integer can be. So you can literally store numbers in the billions or trillions in a variable like so. So that would be maybe something like that. That's something to note too. Now, there's another primitive data types will be the float data type that we want to consider. So with the float data type, it's a floating point number. It represents numbers with decimals. It's useful when precision matters like scientific calculation or financial applications. So that would be maybe say if you're checking like something like a price, and then you have 9.99, that gives more precision compared to just having 19. And then obviously when you're talking about gravity equals to maybe 9.281, so you could consider that too. And then the other say constant values like pi, you have 3.14, right? 14159. So those are kind of here. That's how we consider that we have numbers with decimal points, Python automatically it traces as float points. So an important thing to note too is that if you divide two integers in Python using the forward slash, the result will always be a float. Maybe you're dividing, say, 9 divided by 8. The result in this case will always be a float. So we could check that in terms of confirming if we will have a float for this case. So we're going to have Python, then data, and then now you can say 9 divided by 8. Obviously, that since it has decimal values, but you could have also 9 divided by 9 so that you can have that check effect. And then that will be 1.0, right? So instead of just giving you 1, it's going to give you 1.0. That's something to consider too. Now, there's another data type that you'd want to consider. That is the Boolean that we talked about, Boolean data type. Now, Booleans are simple. They only have two possible values. That is true or false. So the possible values will be they are super useful for making decisions in code. So really, we're gonna see that in the subsequent sessions in terms of how this helps us in making decisions and how to go about that. Now, that means that if we're looking at an example, we could look at an example of maybe say is Python. Remember, we're creating a variable for this case. Is Python fun? And then we're gonna say true, right? So that's our value, right? That's our value for is Python fun. Okay, so you can always have this here. If you get to run our code, then you're gonna get an output as true, right? The Boolean value that you're considering. Also, Booleans are often the result of comparisons or logical operators, which we're gonna be diving into deeper later. But you could see kind of an example whereby, for instance, you're gonna say you could say 4 equals to 7, and then if you go ahead and print that, you're gonna see that you're getting an output as false. That is what I'll be getting when doing comparison operators. And we're gonna dive into this and understand the combination of comparison operators and logical operators and how we have the outputs or how they return Boolean values. Now, the other thing is that Booleans can also be treated as numbers. By this, I mean true mostly will act as 1, and then false will act as 0. That's how we'd be able to treat them as numbers. So that means that you can add a value with the Boolean values. So for instance, we can look at something like print, and then we can say, hey, print 10, and then plus true. And then obviously for this, we're gonna consider true as 1, and then we should be able to get an output as 11 for this case. So let's run that, and then we're gonna see our output as 11. Now the same applies for now if you calculate, say, false. So if you have false, then the fact that it's 0, then it's gonna just output 10 for us. So we're expecting 11 and then 10 as our output. Now sometimes we need a variable that doesn't have a value yet. That's where the none comes in. Essentially just represents nothing. So, or obviously that will be empty, just represent nothing in that case. So for case, that means that with if for instance we have a result equals to, and then we could have none. So with that, then that means that if we print out result, we should get the output as none, given that you'd have nothing in that case, right? Remember, this will really help when, for instance, it's often used when we don't yet know what the value will be, or when we need a placeholder for a code, yeah, right? So, because remember, we can have something like result equals, so you're gonna empty like that. So, for in this case, then that's where the none comes in as a placeholder to a placeholder for a result variable as an empty. Say empty value, and then you're gonna update that later. Now a string is simply text, so there will be like names, right, or even sequences of characters. Those are the kind of things you to consider with the string. So there will be something like you're considering a greeting, and then you have something like hello, morning, something like that, right? And then simply put, that means that we're introducing another function. And in this case, we're going to say, hey, print. And then we're going to say list function, and then have the text there. So for a case, you should be able to create a list of our, say, string that you have. Now, a list, as we mentioned up top, is a non-primitive data type. We're going to be delving into lists after the primitive data types, and then kind of understand the nitty-gritties. But in this case, just get to understand it in this context. So if you run that, then you're gonna get it split into all this, say, different, say, in a list, that is, with the individual characters showing like so. That means that if you have it as a list, a very, very interesting concept that we'll be learning too in a list, that is slicing. But in this case, we're slicing a string. So that means that you can pick a part of your string values. So for instance, for our case, we can say print, and then now that we have, say, our word text, we can say, hey, we need the text from maybe 0 to around 4, or maybe even 3. So that'll be 0 up to around 3. That will be around somewhere here, pyt. So if you run that, then we get pyt. So that's the bit of the slicing. We're going to be talking about slicing in list, which is obviously, and slicing in non-primitive data types, because they hold multiple pieces of data types or multiple pieces of data, and that's why something like slicing will come in handy, because they have multiple values, if anything. Also, something to note is that when selecting part of the text using start, you'd have start and then the end, like so. That's how we'd look at it in terms of now when you'd want to select the kind of the portion of values that you'd need to work on. That's how the slicing will look like. Great job. Now you know about primitive data types. That is numbers, booleans, none, and text. Just a quick recap is that we started on primitive data type, whole single values. That's something to note. And then we talked about the individual data types, that is integers, which is whole numbers, and then float, which is decimal numbers, and then we have booleans, which is true or false, right? And then we have none type, which represents just nothing or emptiness. And then finally, in the primitive data types, we talked about strings, which represent texts. Next, we'll explore something even more powerful, that is non-primitive data types or data structures. This allows us to store multiple values in a single variable. As we mentioned earlier, imagine this. You're organizing your closet. You have different types of things, clothes, shoes, accessories. Will you just throw everything into one messy pile? Of course not. Just like you need shelves, drawers, and boxes to keep things neat, Python has something similar, and that's the primitive, non-primitive data types, that is data structures. Data structures helps us store, manage, and organize information efficiently. And we're going to explore the different data structures that do that. In this part, we're going to be understanding what are data structures and why do they matter, and the examples, that is the lists, tuples, dictionaries, and sets. Now, let's start with the list as the first data structure that we'll be looking at. A list is like your backpack. It can hold anything, that is books, a laptop, snacks, and even another small bag inside. And we're gonna see this in action. So first thing first, we could start with maybe creating a list routes. Then for case, we're gonna use square bracket and then have apple, and then banana, and then cherry. This is the structure of the list and how it will hold, say, values. So for case, what you're noticing is we have square brackets when initializing or creating a list, and then we have values inside that list. So in this case, if we go ahead and print out the fruits, we're gonna be getting, say, banana. That should be apple, banana, orange, the whole list. That is. Then something interesting to check is you can always also use the type function, and then with the type function it should be able to show you or tell you that, hey, this is a list, and then easily you can understand the data type that you're working with. We're going to be diving into something like the type functions, then get to understand the nitty gritties into it and how it will help you understand the different data types, and then how to align different data types. Or in understanding the type of data, you can easily know the methods or how to work around the specific data types, given how different the data types are. Now we have a list here, a list of rows in this case, but guess what? A list can also store any type of data. So that means that we can have something like maybe random stuff. And then in this case, we're going to have maybe value 23, then hello, and then none data type. And then now this time we can have 3.14, and then we can have fruits, and then we can have true. And that means that it can even hold another list that, for instance, the fruits list that you have here. So that's very evident. So for case, that means that if you go ahead and print random stuff, and then we go ahead and run that, we're going to see like, hey, we have a list of values, and then something to note, kind of see now another list, that is the fruits list inside our random stuff list. So we're going to demystify this, get to understand how this comes about, and if anything, this is where now we'd call it a nested list. List inside that list. We're going to be expounding on that. But before that, we want to understand how you'll be able to pick different values or access different values of a list, that is. And then obviously, more than that is how will you be able to pick portions of data in a list. And that's what you want to look at now. Accessing items in a list. And in this case, obviously, you talk about indexing a list. So with the indexing, what happens is you're just accessing a particular item. And for a case, we can say maybe print, and then you have fruits, and then you want to access a specific item, maybe say apple. that will be 0. And then we're going to talk about the indexing bit too. If you run, let me clear, then if you run that, then you're going to see we're getting an output as of Apple. So that now brings up a question around how indexing works in a list. And the indexing will be starting from 0, 1, and then 2. So you'd always be starting with, say, 0 when indexing a list, and then 1, 2. So that's how you'd walk around indexing or accessing values. So remember, this is a constant for any list. Obviously, that means that when you're creating a list, it already has all this that you can reference, that is the indexing bit. And that's how you'll be able to access values. So that's why you'd have indexing a list here. Also, that means that you can also do negative indexing in this bit. And that will mean that instead of starting from 0, 1, 2, you can start from your right going to your left. And that will be -1, -2, and -3, right? So you'd have it like so. So that means that obviously for the negative indexing, you're noticing that we're going to be starting with -1, -2, and then -3. That's something also to note. So that means that if you do want to pick something like a value like cherry, you'd notice that for case, that will mean that just go ahead and then you can say, and just copy this, then have it here, and then now this time, that means that will be -1 for case. So for -1, you can go ahead and run that, and then we're going to get cherry. And then obviously that means that for even getting now banana, that will be -2. And then if you go ahead and run that, you should be able to get banana in this case. So these are things to note in terms of the negative indexing that you do. So it really helps you easily access the last value. So for instance, for a random stuff list, you can go ahead and say print random stuff, and then you can just have negative indexing and have it pick the last value right away. And that will pick the last value. That is true. Okay, so we're able to see that here. The other part of accessing items in a list that we want to consider is the slicing. So obviously, slicing a list, and in this case, what's happening is you accessing a portion of the list. So that means that, for instance, for a list here, you don't only want one value or item, but you want several values or items. So that would be, maybe say you want banana and cherry or apple and banana, then that's where the slicing bit comes in. So for our case, we're going to look at that and then see how that works. So for case, we're going to say something like fruit and fruits, and then square bracket, and then now we're going to provide, so note, for this case, we have the structure that we'll be slicing with. We'd have our square brackets, and then we're going to have our start and then end for the bit of the slicing that we're doing. So we'd have it like so. So we'd have our start value and then our end value. And then something to note is our start value is obviously inclusive. We're going to see how that works. And then our end value is exclusive. That's it. Let's see this in action. So we're going to have, say, our fruits. Oh, we have fruits already. So we're going to index, say, starting from apple to, we want to index, or we want to pick that is apple and banana. So we're going to have something like this, right? And then now if we go ahead and run that, so we're going to get apple, banana, right? Now, something to note is what we mentioned earlier about the bit of the start and end. So we mentioned that start would be included obviously, and then end would be excluded. So what you're trying to say is 2 will be excluded and then 0 will be included. So that means that you'd have 0, 1, and then it's going to pick those two. And that's what you're seeing as our output here. Also, it's important to know that in slicing, you can also have something like this. So obviously, without referencing the first value, that means that you should be able to start from the first value. That is. So could do away with this, and then obviously in this case we'd be expecting the same value or the same output for a case, and you're seeing that, right? So not unless now, if you're starting from index 1, then you'd have to specify that. In this case, maybe have 1, but if you're starting from the start or from the first position, then you don't need to specify that. So obviously, starting from 1 should only pick 1 in our case. Now, that's slicing and how you'd be able to pick specific indexes, the range of indexes, and then use that. Now, the other bit is we could also use the negative indexing, whereby you're starting from right to left. You're indexing from right to left, right? And that will look something like this. Also, you could consider having a step size that will look something like this. So you'd have the start, the end, and also the step. Obviously, with the step, this dictates how many items you skip over while slicing. So that will look something like this. So for instance, if we have our values, if we now print again fruits, and then now we're gonna start from 0, and then wanna take up to 3, or 3 in this case, and then wanna skip 1. Then that means that it should give us all the values, right? So if you run this, so you're gonna be getting apple, banana, cherry. So that means that is skipping 1 value. Now, if you change that to 2, then it should be able to skip 2 values, and that means that you're getting apple and cherry. Now, apart from considering this format while slicing, you could also include the step size. Let's see how that looks like, but this is how we'd have it. We'd have the start, the end, and the step. So that should consider the bit of the step should just consider how many items you skip over while slicing. So that will look something like if you have print fruits, and then you have 1 or 0. Maybe you could have 1, and then say it'll be 3, and then have a step size of 1. Then that means that now when we look at the fruits list, we're gonna start at fruits, and then it's gonna move 1 position, that is to the next, and then another position to the next one, that is. Now, if we look at the fruits list, then for instance, if you are looking at index 1, we're starting with the index 1, it's gonna look at start at banana, and then move 1 position to cherry, and then that means that it's gonna just pick banana and cherry. So since obviously they are 1 position beside each other. So if we have that like so, then we can go ahead and run this, and then we're gonna get that should be banana and cherry, right? Yeah, banana and cherry in that case. Now that's that's obviously with the step of 1, right? Remember the steps dictates how many items you skip while slicing. Now, if you have 2, then that means that it's gonna start at a banana, and then it should be able to skip this, and then find the next value, maybe here, but it doesn't. There's no other value, and in that case, we're gonna just get banana as the output. So we're gonna run that, and then we get our output as banana given the steps. So you're looking at the positions, and then you're looking at the distances, the positions that it skips over, and then at the same time the start and the end, that is in this case. Now we could go ahead and look at negative slicing in that case. So negative slicing for case will be something like if you print fruits, and then you'd start with, you could say, let's start with negative 2. Now for our case, negative 2 will look something like this, right? So that will be banana in our case. This one will be -3, and then -2, -1. That will look something like so. Now, -2 will be banana. Now that means that it should be able to take values from banana onwards, and that means that it should be able to give output banana and cherry. So we're gonna run that, then see our output. We're gonna see our output as banana and cherry. With that said, then that means that you can change this to -3, and then it's gonna pick -3 onwards while slicing, that is. So that should be all the values, all the fruits that you have. So apple, banana, and cherry. Now, at the same time, you can have, say, -1, and then that should be able to, say, give you cherry in this case. Now, awesome. So that's how we'd look at it, if anything. So, and then play around with that. So you can use the negative slicing in this case to be able to work around that. Now, that said, let's look at now another interesting thing, the negative slicing, and at the same time using step sizes. For instance, if you'd want to reverse your values, you'd go ahead and utilize the concepts that we've had with the negative slicing and the step size. That will look something like fruits. We can have like so, and then -1, right? And then I could let you guess what you think the output will be. Obviously, so for this, then the output will be kind of the reverse index. Maybe you might have thought something like a cherry, having an output of cherry or something. But in this case, what will happen is that have all the output, but reverse in this case. So you're going to see like we're starting with a cherry, banana, and apple. So in that case, now with the understanding of negative slicing and with the step size, you finally get the output or reverse your values as such. Right. So now let's open this up and then just get to understand how this looks like in terms of when reversing your values. Now, when reversing your values, something note is you'd want to consider what we talked about earlier on. So whereby you have the start, and then you have end, and then you have the step size or the steps that we'll be considering. In our case here, we have this format. This is that now we don't have it open. So for instance, if we have before the first column, we have 0, you're considering 0, everything from the start. And then, yeah, in the middle, you don't have any value. And then we have -1, right? So that says that start from 0 onwards. But in this case, it's going to do reverse for the same while starting from 0, right? So that's the case. That's the understanding in this aspect. Now, in this case, we're considering this will give us a reverse of the values that we have, as you're able to see here. So kind of with the output here. Now, what happens with this in this case is the absence of the start. So remember here, if you're considering the start and our step size. So in this case, we have a step of -1, and then we have start and the start and end is absent. This means that the slice will consider the entire list. So with the step size of -1, that means that the step size will indicate that Python should start from the end of the list and move backwards, effectively reversing our list. And that's what you're getting as the output here. Now, we're going to look at a different scenario, almost similar, but what you're looking at is, what if we have a start for the same? So we're going to have something like, hey, instead of having it as it was before, so we're going to comment this, but have maybe say something like 2, right? So that means that if we have 2, then we're going to consider our indexes like 0. Remember with the 0-based indexing, 1, and then 2. So we're going to look at this and then see how we get the output. So that means that 2 should be cherry. Then if you're doing step size of -1, so that'll be negative step size, and that should start from cherry, banana, and then apple. So essentially, we're expecting the same value as the reverse indexing here that we got there. So if you run this, then we're going to be getting, say, cherry, banana, and then apple, right? So similar scenario that you had before. Now, that said, to just make sure that this, we're going to have another example, maybe use a different value for this case, and then see how this will work for us. So let's say we'd want to pick banana and apple and banana and reverse that. Then you do notice that we could start with 1, and then it's going to reverse that for us, right? So it's going to start from 1, and then that should mean that it should do negative step size for the same. So obviously for a case, then that means that you should be expecting getting a banana and then apple, right? Awesome. So that's how you'd look at, say, the step size. Now, having talked about step size and negative slicing, we could look at list reassignment, right? So this is where now you do want to change a particular value, say banana, and have a different, say, fruit. So let's talk about that. So that will be something like, for instance, we want to change banana to a different fruit, then we're going to use reassignment in this case, and that will look something like, first you're going to call the fruits, and then index the specific value that you want to reassign. So for case, we have it as 1, that is the banana, and then provide a value in this case. So our value will be pineapple, and then now we want to print out, say, fruits list, and then we're expecting that now the necessary changes has been made. That is from banana to pineapple, and that's list reassignment. But by now, you want to consider first the index, right, of the value, and then provide a new value. So, or reassign a new value. So that's how it go about list reassignment. Now, that said, I want to talk about now a list inside this list. So remember the example that you had previously, the nested list. So want to kind of look at this and then see how that works in our case. So let's have it here. And then now we can talk about nested list. So for the nested list, up to now, you do understand like a list can hold different values or different data types. That is, it can also hold a list itself. And that's for our case, we have fruits in our case. And that's in that aspect, then you're considering that we have it as a nested list. That's a list inside a list. Now, something important to note with a list inside a list is kind of the bit of the indexing that you'd have for the same. So I'm gonna try print this out and have a look at. So these are the values. So this is the nested list, right? So the fruits list is the nested list here. So you could pick all of this, then have it here. And then now we're gonna work on indexing that, right? So first of all, the first thing will be I want to look at the bit of the indexing, right? So for instance, if you have a nested list, then what will happen is that you're gonna just start your index just as normal, right? So the nested list, the whole nested list will be a whole index, and with that I mean something like this. So it have would set our value here with 0, then we have 1, and then 2, 3, 4, up to 5, right? So with those indexes like so, then you do notice that for our fruits list, we have it as index 4, and that's how we'd be able to consider that. That means that if we come here, then all of this list will be index 4 under the parent list, if anything, and that's how we'd consider it. So we'd go ahead and pick the necessary values or the necessary indexes for the list that you have. So for instance, for a case, you have 0, and then 1, then 2, right? So let's look at that. Okay. So we're gonna say, hey, let's index 4. So that would be 4, like so. And then after indexing 4, let's print that out. So if you print that out, then you get that should be apple, pineapple, cherry. Okay, those are the output that we're getting. And then obviously, when you're getting that output, that should tell us that there's a list, there's another list that we're considering. So to confirm that there's a list, use the type function in our case. So we're gonna use the type function like so, and then now try run that, and then obviously it's gonna tell you like, hey, there's a list. And obviously, as long as it's a list, then you're gonna use the list functionalities to be able to manipulate the different values that you have in your list. So obviously, in our case, then that means that if it's a list, we're considering that as a list. Then if you wanna index maybe pineapple, then that will be another extra index, given that it's a list like so. So you're gonna have your value like so, and then if you run this, then we should be getting our output as pineapple. So that's how we index a nested list. At the same time, when you look at say something like slicing, it's gonna be just similar to what we talked about. You could slice values around your values, including even the nested list, right? So for instance, for case, I can say something like maybe say we want to start with 4 nodes, and then that should give us outputs from our nested list. So we have our nested list here: apple, pineapple, cherry, and then true. So that's a bit of the slicing that we do. Obviously, that means that if you do want to go ahead and slice your nested list, that should look something like as indexing the nested list, and then now slicing your index your nested list. So that should give us values pineapple and cherry, given that you're indexing now the nested list in our case. Awesome. So the other thing that we want to look at is the reassignment in a nested list. And for this one, as long as you are aware of the different, say, indexes, right, within the nested list, then you can easily reassign a value. So for instance, for case, we could easily pick this here. And then now that means that for case, what you're doing is that with index 4, we pick the our nested list, that is fruits. And then now we can go ahead and index that again, right? The nested list. And then for case, that means that we can even index index 0, and then say grapes. And now if we print out random stuff, that should give you values like so. So it will change that. Notice change that apple to grapes. Nice. Now we understand, say, slicing, indexing, slicing, and reassignment, both for list and also the nested list. So we're good with the concepts around list, most of the concepts around list. And what you're saying is that when you want to pick a value or say, access a value, then you're going to use indexing. And then when you're slicing, then that means that you're just taking a portion of values in your list. And then at the same time, when you do want to change a particular value in your list, then you can use reassignment. Now, at the same time, what we'll be doing is we want to introduce now other functionalities. Let's say you don't want to add another value to your list, or let's say you don't want to remove a value from your list. So now the list methods comes in. So now this part we're going to talk about list methods. And one example is append. So let's say you don't want to add another value to your list, then you'd use the append method. So we could say something like fruits dot append, like so, and then we provide a value that you don't want to. Maybe say, let's say you want to add mango, then we'd have it like so, and then now that means that you want to print that out. That will be fruits, and then want to run that, and then we're gonna see that now we have another extra value that is mango that is appended. So that's essentially the use of append method, and you'll be able to use it to add another value. Now, that said, now something that I've forgotten to mention or to demystify is the methods, the what type methods. So you can think of methods as functions specific for a data type, right? Now, the data type that we're considering in this case is a list. And yeah, so that's how you think about it. So later we're gonna have some broader explanation into what methods are, but in this case, then we can think about it like so. Now this is append, so we've seen that, and so for a case with the append, we've seen that you're just adding, say, another value to your list, and that's where the append will come in. Now there's also insert, which will also help you add values, and it has a format whereby you want to provide an index and then provide your value. So in this case, it solves for the case whereby you'd want a value in a specific index. You'd notice that for append, it's going to have the value as the final index in this case. Now for insert, you want to provide the value and the index and then the value. So that means that, for instance, for a case, if you're looking at our values, that is our case here, we have fruits that we'll be looking at. Then if you want it in index 1, so it's going to get in between grapes and pineapple and then push all the other values aside. So that's what you're trying to look at. So for a case, then we could just go ahead and say fruits dot insert, provide the index. Say for instance, for a case, we don't want it in index 1, and then maybe provide the value. In this case, we can say coconut. And then now, if we print fruits, then we should be able to have the values pushed over, then allow space for our coconut. So coconut should be able to take the current updated index that we have. So that's insert. The other method that we do want to look at is remove. So whereby in this case, that means that we should be able to remove values. So we can have dot remove. And then now in this case, we'll be providing the value to remove. So let's see how that looks like. Let's say we want to remove maybe say a value like cherry. We're gonna say fruits dot remove, then provide now the value that is cherry, and then now if we go ahead and print out our fruits or display our fruits, then we should be able to get to have that cherry is no longer in our list, and that's how we'd have it. Now, at the same time, let's also look at another method that helps you remove values. That will be pop method. And for a pop method, we're gonna see it's different, how different it is to remove. We can have pop like so. And then what should happen is that if we print our values, fruits, it should be able to pop out or remove the last value. So if we run this, then it should be able to remove the last value, which is mango. So now we no longer have mango. Now, the other interesting thing with the pop is you can now provide an index value. Now, maybe unlike remove, whereby you'd have to provide the exact, say, value, name, pop, you can just give an index, right? So we can say, hey, with the remaining values or with the remaining values that you have here, you don't want to remove maybe something like coconut and it's in index 1, then you'd go ahead and provide 1 there. And then if you run that, you should be able to remove that specific value given the index. Now, other functionalities that might be interesting would be maybe say using in operator. And in this case, say you want to check or find if a value is in your list, then could check our list first, that is fruits. Then we're gonna run that, get our output as grapes, pineapple, and mango. Say for instance, you wanna just check if you have pineapple in our list. You're gonna have something like pineapple. So, and then in fruits, and then that should just check or confirm if pineapple is in fruits. So remember, In such a case, then what will happen is you'll be expecting a Boolean value. Given that you'll be expecting a Boolean value, that is either true or false, then we could print this, we could wrap this around a print function, like so, and then run this to be able to confirm to us if it's true. And then again, it's going to tell us, hey, that's true, there's pineapple in fruits. The other interesting stuff to look at is concatenation in list. And simply put, this is just whereby you wanna combine values or combine lists together. Then you're gonna use concatenation, whereby you should be able to combine one list with another list that you have. Let's say we have a concat list that you're considering at the moment, and then we could say, maybe say have values like 23 or 90, like so. So we have our values 23 for 90. We could concat the list with the fruits list that we have. So we could have fruits list, like so. And then it should be able to combine this into one huge list. Let's see how that looks like for case. And then let's print that out. And then you notice it's gonna combine all this. Note that there's no nested list here. In this aspect, what is happening is that it's going to combine all this together into one huge list. And then that means that it's going to obviously update to new indexes for other indexes, that is, or maybe the fruits list. So obviously grapes in our case here would consider it as index 3 now. So that's concatenation and how it look at that. So these are fancy things like maybe say we'd want to make a copy. So maybe list copy. Make a copy of a list. So maybe you could have concat.copy. And then in this case, you should be able to copy the previous list without modifying the previous list. Essentially what's happening is if we now want to modify say list copy, then it won't affect our original list. That is the concat list, right? So we have the list copy here. So remember, we can even change that. So we can say maybe list copy.pop. And then now, obviously, expecting that to be changed, and the other one stay the same. So we have change there. So obviously, mango has been popped out, and then we have the original list as it was. Awesome. So up to this point, we've really learned quite a lot around our list and how it go about that. So essentially, what happens to the list is the main pointers is how to create a list. Awesome. Now we've covered a lot about lists in terms of understanding how it work around lists. We're gonna pick up on the next, say, data type, that is tuple, and then see the differences of tuple to a list and how that looks like. So for case, just a quick recap, what we've been discussing in list is understanding how to create a list. That's very, very important. And also remembering that it holds multiple values. We have our fruits list, which is apple, banana, and cherry. And then at the same time, we learned how to access different values or different items of our list. And then the other thing is the bit of the slicing. Something to note is the step sizes that you have with the list, whereby you have start, end, and step. This step should dictate how many values you're skipping over while slicing. So for instance, if you have a step of 2 in this case, then that means that you're skipping 2 positions in that case. Then we talked about negative slicing, how it go about that. Obviously that'll be off of that now, the negative indexing that we talked about before, and then now introduce kind of combining negative slicing with the say step sizes. So how that will look like. So for instance, for this case, we saw how like you can reverse a list using that. So that will be the -1 step size. And then obviously here too, we have -1 step size. That should help us reverse the list output. We talked about reassignment. That is, if you want to reassign a different value, then something to note is you want to pick the specific value index first, and then after that, you should be able to reassign the value. Now, we talked about also the nested list, whereby in this case, we're talking about a list inside a list. And we kind of talked about, we expounded on a random stuff list that we had. It contains the fruits list. And then we saw how you'd index a fruits list. And then after indexing a fruits list, if you want a value like pineapple inside that list, then you're going to have another extra index like so. And then at the same time, that works similar to, say, slicing. And that's how we did. So whereby if you want to slice values from index 4, then that would be fruits, the fruits values, and then true focus. And then obviously you can narrow down to your nested list. And then after narrowing down to your nested list, you can now also slice that too. We talked about reassignment in a list. So you want to just understand the indexing that plays around with the nested list and the specific values. And then from there, you can easily now reassign a value. We also talked about methods, list methods, which now should give us other robust functionalities to manipulating a list. And in this case, we talked about something like .append, which should be able to append values or add values at the very, very last index. And then now we talked about insert, which is a little bit different, whereby we provide the index and the value that we want to add to the list. Remove should be able to remove values, and then pop should be able to pop out value. And for in operator, it should be able to check if there's a value in a list. So for instance, in our case, we're trying to check if pineapple is in the list, and then we should be able to get a Boolean value that is true. And then concatenation or concatenation a list, whereby now we're combining a list together to create one huge list, and that's how you'd have it. So in this case, then we'd use the plus operator, right, to achieve that. And finally, we talked about .copy, whereby you should be able to copy your list. And then now when you make changes to the copy list, it shouldn't affect the original list. Now, up to this point, we've covered quite a lot in lists. So we'd want to move to tuples and understand the aspect, and I'll kind of compare that to the list and other data types. Okay, awesome. Now, let's talk about tuples. Think of a tuple like a contract. Once it's written, you can change it. Now, that's the main difference between the tuple and the list. So in this case, you can say like tuple is immutable. So that means that after having your values initialized, you can't change them. Let's look at an example of how that will look like. Maybe say we have variable colors equals to, and then we're gonna say we have red, and then we have green, and then you have blue. So now if we review what we talked about in a list, then it's going to be indexing a tuple. And then we can also slice a tuple, right? So a bit of the indexing to just be similar structure to a list. There'll be colors. If you want to pick red, then we're looking at starting at index 0 like so, then 1, 2 like so. Here, with the indexing a red color, then you could have it like so, 0, and then we're gonna print this out. And get our output as red, right? So in terms of every other thing, similar to a list, it is that now can be changed, and that's the main difference that you don't note. Now let's see how to slice a tuple. That will be print, and then it'll be just similar. We're gonna call it the colors tuple, and then that means that maybe you wanna pick from 0 to say 2. Then if you run that, then you should be getting that. You should be getting green and red and green, and obviously the index 2 excluded, that is. Now we've seen how to create a tuple, and that's how we go about it, creating the tuple, that is. Now the other thing is you can also um, keep using the parentheses and while creating a tuple, and that will look something like this. Now we've seen how to create a tuple, and you just have colors equals to, and then you notice that you'll be using the parentheses for the same. You can also, another way is also you can skip the parentheses while creating a tuple, and then Python will automatically convert a comma separated values into a tuple. So that will look something like, maybe say if you have tuple numbers here, nums, and then equals to, and then we have maybe 34, then 20, and then 6. So this will automatically be converted to a tuple in Python. So if you go ahead and say tuple, there should be tuple nums, like so. Then if you run that, you should have it in parentheses, right? So that's how I'd look at it. Now, at the same time, obviously, to confirm that too, you can always use the type function, and then that should confirm to us that that's a tuple data type. So it's going to tell you like, hey, that's a class tuple. So that's a tuple data type. Awesome. So that's how we'd look at that. Now, there's also the bit of tuple unpacking that you do want to consider. That will be creating multiple variables with a single statement. So that will look something like, say, we have countries that you're considering, and that will be maybe, say, for a case, we can have here, we can say maybe Thailand, and then we can have Serbia. Now, now we can go ahead and unpack that like so. So we're gonna say country one, a comma, country two, and then that should be countries. So with that, obviously, we're expecting it to take the specific positions that you're defining for these countries, right? So that would look something like the country one should obviously take the position of similar position to the Thailand, so that obviously it's gonna reference Thailand, and then country two should take position two. They should obviously reference Serbia. So in such a case, then if you go ahead and try print this, let's say country one, like so, we should be getting our output as Thailand for country one. And then now, if you change that to country two, that should reference country two in our case, and that will be now Serbia. So that's how you'd create multiple variables with a single statement, as we've seen. And then now, at the same time, this is where what you can also call tuple unpacking. You're literally unpacking specific values given their positions. Another thing to mention is you can also use the tuple function, right? So that will look something like that. And for the tuple function, you should be able to change your values to tuple. So for instance, we reference fruits list, and then now we'd want to change them to tuple. So that would be tuple like so. And then we'd have fruits there, like so. And then now, if we run this, we should be getting our output as tuple now. So we're gonna get the first one obviously was a list. That's why we have it as a square bracket. Then the second one is a tuple. With what you're seeing with tuples is that when you need a collection of things that should never change, you don't want to use a tuple. Nice. So now let's talk about dictionaries. Another Python data types and primitive one. Now imagine having a digital assistant that remembers things like names, phone numbers, birthdays, etc. That's a dictionary. An example looks something like this. Maybe you have a person, and then they say equals, and then now you're going to provide a name. Now let's look at modifying a dictionary, or in this case, modifying our student dictionary that we have. So I'm going to say modify dictionary. So for case we want to just modify the specific values that we have, maybe say we could start off by modifying the age. So we could say that means that you'd want first to consider the bit of the indexing that we did earlier. So the indexing or accessing of the values. So accessing of the corresponding values, the key. So we could say age for case. And then now that means that you're trying to access age. Remember, if you go ahead and print this out like so, you're gonna get 24, which is our value that we want to consider in this case. So if you have that, then that means that you want to first pick the key and then be able to now get its corresponding value. So for our case, we're changing key's value, and that's what we are doing here. So we could change that to maybe 21, like so. Then now, this time, if we print something like student, all the dictionary itself, then we're gonna get that changed, right? So the age for our case is changed to 21, and that's the bit of the modifying. Remember, in this case, this part we did talk about it in a list, and a list will look something like if you have list num, or for our case, if you have fruits list, and then you're indexing value 1, then equals to maybe say mango, like so, and this will be a list reassignment. For the modification that we're doing here, you can just think about it as reassignment of in a dictionary, that is. So remember, you can do this for the different keys, right? So you can just have a student age, and then obviously in our case you can maybe change this for maybe subject. If you have new subjects, you could say student, and then that will be subject, like so. So obviously you're providing the key, and then now we could have another list of subjects. So that will be maybe physics, and then maybe Python, programming, like so. So if you consider something like that, and then now we get to print the student, then we should be able to get that now our subject is changed, and that's physics and Python programming. So that's a look at it. That's of kind of playing around with dictionaries, and even to this extent modifying that. Now imagine we're modifying a dictionary, but we want to add a new value. Then we're going to use assignment, the same assignment operator or assignment strategy that we had for this one. So that means that we're going to have student, and then we want to add maybe address or place, and then I'm going to just provide where the student lives. So that will be the state or something like so. And then now this one should create a new dictionary for us. So if we go ahead and print student dictionary, then we should be able to get an output that we have now an address, like so, right? Awesome. So that should give you the address output that we've already added. Now, okay, that means that if you would want to add, maybe say even kind of having a score or something, getting a student average score for the subject, that'll be average score. And then you can go ahead and have our value maybe at 29. And then that should be able to create a new dictionary for you. So you go ahead and run that. So we should be able to get this added, the average score. So that's the key and its value. And that's how we can add a key and a value in a dictionary, that is using the assignment operator. Now, that said, that means that after getting such an update, then that means that if you want to create, if you want to pick a specific, say, key, then you can go ahead and just have it like so. And that should be able to print or display the specific key that you'd want, right? So for our case, we have the value for our specific key, that is 79. After, if you want to pick average score. An alternative that I wanted to point out to be able to pick a specific value of a key will be you can have print, then student, then dot get. So there's the get method. So there's the get method for accessing data. So you'd have get, and then now in this case you'd go ahead and specify student dot get, and then that means that if you'd want to pick maybe address, that will look something like that. So you specify your key, and then you should be able to or get or pick the key for you. That is the value of the key. So that will be granted state for address that is. So that's also something to consider also. Let's say you want to check if there's a in your dictionary, then we're gonna use an in operator. Whereby for case we're gonna say something like you're gonna say name. It's name in now the student dictionary for case. So obviously we don't want to display that, so we wrap it using our print. Now if you run that, it should give us true, right? So that means that obviously the name is inside the dictionary. So we could change that to address. And then if you run this, then it should tell you like, hey, the address in the dictionary. Let's maybe remove one S, obviously. So you can guess what you get as an output. That will be false, given that you don't have such reference in our dictionary. Now, still in the spirit of modifying a dictionary, you think of other operations. Maybe say, for instance, for case, we've seen how we can add another key and value, and then at the same time modifying a specific keys values. And then now there's the aspect of now if you don't want to maybe say remove a value, how will you go about that? So that's something that we're going to look at, right? So we're going to say now if you do want to okay, first of all, let me just remove this here and have them up top in this section of accessing, right? So this will be accessing the specific values. So for case, we want to talk about removing value. So for case, that means that we can easily use .pop method. And remember, we use this method in lists whereby you have .pop, remove the last value, and then you can specify a key to effect that. Now, we'll be talking about the same structure whereby you have student, and then we could say maybe want to remove maybe age, so that would be pop, and then provide the key, right? So remember, we provide our key here, and then for the same time with the list, you'd also provide your index value. So we'll have it like so, and then for our case, to be able to see that, to get to confirm that the age is popped out, you want to print out the dictionary student. So that would be something like that, and then we're gonna see that hey, we no longer have age in our dictionary, right? So that's how we look at it in terms of pop. Remember, now after having that, it could, when you're popping out a value, you could also print it out, right? So by hey, which instead of just asking what value have we popped out, so with that, it's gonna kind of give you a value that is 21. So tell you like, hey, you've popped out age, and that's also dictionaries provide methods to view the list of keys, values, or even key value pairs inside it. And in that case, we're gonna look at some specific methods such as keys, and as the name gives away, should be able to show us the keys in the dictionary. So we're gonna, in this case, just having student, then dot keys like so, and then this should display or essentially just print out all the keys. So if you just run this, then you're gonna see like, hey, what's doing is gonna tell you dict keys, and then as a list, show you all the keys that are there. So the name, subjects, address, and the average score. And this should just tell you right away, like, hey, what are the keys that you're working with? And with that, you can easily now narrow down to the specific key that you'd love to use. That's the dot keys. Now, let's say, obviously, there's also now the dot values method that you could use. In this case, similar to how you'd use the keys, you just say dot values, and then now we'd want to display this, have print like so, and then now if you run this, then it should be able to display only the values that you have. In this case, in a case where you don't want to just check the values of your dictionary, then they should come in handy. Up with that. Now, that mentioned, there's also now if you don't want to see kind of get both of them, right? So if you don't want to pick both the keys and the values at the same time using your methods, so that will be the dot item methods, and that will look something like student, and then dot items, and then we'd want to display this like so. So in this case, if you go ahead and try to display that, you should be able to display each key and its specific or corresponding value. So for instance, name, Shelley, and then subjects, physics, Python programming, and then address, you have Grand Estate, and then average score, you have 29. So that's how you'd have all this kind of workout, whereby if you don't want to pick a specific key, then you'd use the keys method, specific values off of the dictionary, then dot values method should come in handy. And then finally, if you don't want to just pick both as a tuple, mostly you can see the one tuple, another tuple, right? And then we're going to see the use of this while mostly looping through dictionaries or looping through the keys and their corresponding values. So the bit of the tuples will work great with the looping. Up to this point, I'm sure you can tell that if you need to quickly store and retrieve information, then dictionaries are going to be your best friend here. That said, we can easily now move to the next data type, that is the sets. Now imagine you are at a party and you want to make sure there are no duplicate guests. That's what a set does. It removes duplicates automatically. So in that case, then we can go ahead and say that set is a collection of unique items. So unique items, that should mean that it doesn't have any duplicates. With this, we're going to be using, say, parentheses, similar to a dictionary. Except that it doesn't have the colons, it's just the elements inside the curly brackets. Let's go ahead and create set, right? So we can say creating a set. And now we can say something like we have gets, and then we can talk about, say, a list, and then have hope, and then we have Shelley, and then we have a list. Now we can go ahead and print yes, and then see how this would look like. And then you'd notice something, right? So we're going to get our output as Alice, Bob, Shelley. Since this is duplicated, it's going to just give us one Alice. So obviously, if you have this maybe featured as a, say, as a list, that will be guest list. Let's look at an example of that so that kind of get the difference. So obviously in a list, it considers square bracket. So for case you could have the values like so, and then and then change that, have list like so. And then now if we print out our list, you notice that our list has all the values. That is Alice, Bob, Shelley, Alice, right? So gonna capture all the values. And then now, if we go ahead and now print or display or our set, that will look something like that. So you can easily get the difference, right? So you can see for our list, it's gonna capture all the values that we provide, regardless of the duplicates. And then now for our sets, it's gonna give you unique items in this case, whereby just do away with the duplicates automatically. Now we can go ahead and perform some set operations and then kind of see how those will look like. So this will include different set methods that you don't want to use. So for instance, for a case, maybe say you don't want to add some value to your set, then you're going to use add method. So that will be guess, and then dot add. And then now we're going to provide our value that you want to add. Maybe we could add a value here, maybe John, like so. And then now we're going to say print out yes. Then for a case, we're going to get that we have John added. So now there's pop too that it does consider. So pop, as we kind of talked about earlier, in lists and also in dictionaries, gonna be something like just to be able to remove a value. So that means that we can catch the value being popped out by just printing that out like so, and then it should be able to get the popped out value. So if you say Python, there should be data types.py. They should be getting Bob as the popped out value in our case. Awesome. So remember, it's gonna work the same way as we saw in dictionaries. And for case, that will be here. So whereby you use the pop method to be able to remove that. Now we do want to consider the operations that we could use. So those are things like union method. And in this case, we could introduce a second guess list. So that will be guess 2. So that will be our second guess list, and then have it like so, whereby considering maybe something like a name like Layla, and then maybe David. So, and then now, with that, then we could use union, which on both gets values. So, for instance, for a case that will look something like if we display before even display, we could just have guess like so, and then period, and then we say union, and then guess 2. So that kind of combines both of them. So again, this should just combine both of the value, both sets. That is. So obviously, for a case, if you don't want to get a display or an output of that, we're gonna have that like so. And then now we run it. That means it should show us that it's kind of grouping that together. Again, this is a bit of the shuffling bit that we're gonna talk about, but that should just mean if it's a collection of unique item, then the set will mostly be unordered. So it won't be ordered. In that case, then you can consider specific position for a particular that you have, that is. So that's the union and how it works with union. Now, for instance, there's also if you want to find the common members in both, say, both sets. So in that case, you're gonna use intersection method. And so for this case, what it does is I should be able to find common members from both sets. So in our case, you'd notice we only have Layla and David. Then that means that you don't want to even consider adding maybe something like Bob there, so that you can see how that will look like for us. So we could have Bob. Then that means that if you have it like so, if you're doing intersection of intersection of guests, the first guest list and the second guest list, then we're gonna have an output of Bob, given that that's the common member in both of the sets. So in that case, then that will look something like guest dot intersection, and then like so, have guest2, guest underscore 2, and then we're gonna print this out or display it, and then get to see the output in our case. So the output will be Bob, as we mentioned, right? And it's kind of just what we talked about, right? So if you're talking about intersection, then what you're saying is you want to get the common value. There's also the other part to consider, of which kind of finding out our first guest list and the kind of value that is only in the first guest list. And in that case, we're going to use difference method for this case. Then that will be something like guess dot difference, and then guess our second guest list, that will be guess2, like so. And then in this case, what's happening is you should be able to check guest list 1. The guest list 1 is this one, the first guest list, Alice, Bob, Shirley, Alice. And then let's go for a check guest list 2, Layla, David, Bob. Then find values that are only in guest list 1 and not in guest list 2. So remember, in this case, then you understand, obviously, given that this is the common one, Bob is the common values on both sets, then we're going to get as the difference, we're going to get just Alice and Shirley, sorry, for this instance. So if we go ahead and display this, so we're going to have it like so. And then now we're going to get its output. And then this means that we're going to get Alice, Shirley, and then John. So we kind of having John come into, because we did have some add method, or some the set operation that we did start with, that is the add method, and then we added John. So obviously before we get to our intersection part, we already have John added too. So yeah, makes sense. So we kind of so. Now something else to take note of is the bit of the accessing of values of a set, right? Because remember, in our case, you can see like we did emphasize that sets are an ordered collection of unique items, and that means that you wouldn't be considering any indexing in this case, right? So remember, compared to how we have all this here, you can go ahead and have maybe something like square bracket there, and then index maybe 3, that should give you an output of Alice, right? Now, if you go ahead and see that, we're going to have a value like this. We're going to see Alice, right, as the output. So that should be the indexing, obviously. Now, if you go ahead and try that for our set, maybe even 2 or even 1, and then run that, we're going to get an error and tells you like, hey, set objects is not subscriptable. So that goes to show that you can do the normal indexing with the set, and then given that obviously it's also unordered, and then at the same time you can do an indexing. So the only way that you can try check for values is using in operator. Remember the in operator, we use the in operator with the dictionary too. It is right. So but if you want to find if a key is in your dictionary, then you're going to use the in operator like so. It should tell you true or false in this case. Now the same thing going to be happening with that set, whereby you're going to say something like Alice in guess, and then obviously I want to display this, so we're going to use print and then like so, and then now want to run that, and then see if we get an output. So we're going to say it's going to tell you true. We change that maybe to remove one value there, click or something, then we're going to get our value as output false. That is, tells you like, hey, there's no Alec value in the guess sets. That should also mean that if you don't want to index a set, then you're going to change it to a list, right? So you could say yes, and then that will mean that something like a list method, list function, and then that will be like so. Means that In this case, you'll be able to change your values to list. So we could give it a different value, maybe say guess list, right? Then now you can easily index your values. The values that you want, maybe you could say guess, and then list, and then do the last value. We could try pick the last value and then go ahead and like so. We're gonna take the last value. So that means that you're gonna be using all the functionalities, bit of say unique items or kind of removing duplicates. So for our case here, obviously after this is gonna remove duplicates. I'd have Alice Bob Shell is gonna ignore one of the to the Alice, and then after that you can do some operations in the set, that is add John, and then you can do a pop, and then obviously the union, which are methods that you can get in say a list, and then intersection, and then at the same time difference. Then finally you can go ahead and change this to a list, and then now kind of work around the functionalities of our list in terms of indexing, and then kind of accessing a value off of the index, right? Because remember, a list uses both in operator, and also you can easily access your members inside a list using in operator, and then at the same time index. Now up to this point, I'm sure it's pretty clear that sets are great for handling collections where duplicates aren't allowed. And then at the same time, you can use set operations such as difference, intersection, then union for either combining values or finding common values, or even finding values in one specific set that are not in the other. Awesome. So now up to this point, these are the common data types that you want to understand and walk around. So now let's do a recap to know which one should you use in terms of the Python data types, and then specifically the non-primitive or data structures in this case. Again, we mentioned that it holds multiple values. We have lists, tuples, dictionaries, and sets. So in terms of sets, then sets it's best when you need an ordered collection of items that can change, right? So in this case, we're going to have its explanation. We could say ordered collection of items. So remember, the items can easily be changed with the list status. And then we talked about accessing a list. You can use indexing, and then slicing. You can slice a portion of values, and then negative indexing. You can have negative indexing too featured. And then that's where we also talked about, say, also helping with the reversing. So if you have -1, and then you start with the double colons and then -1, then that should do reversing for you. And then we have reassignment that we did talk about, and then nested list, that should be a list inside the list, right? And then slicing in when talking about nested list, and also reassignment in nested list. We also talked about tuples, and tuples are used when you need a fixed and changeable collection, right? So remember, we did mention one of the main characteristics is it's immutable. That is can't be changed, and obviously, as much as it takes the same kind of structure to a list, whereby you can easily index a tuple or slice a tuple. The only thing that can't be done is changing the values of a tuple. We did mention tuple unpacking, and then saw how you could unpack specific variables with their corresponding values. Also talked about now dictionaries. Again, with the dictionaries, remember, so this one will talk about it as an ordered. So remember, an ordered, similar to how set will look like. So the collection of items. So this is similar to how a set would be like another collection of items. The other added advantage is the key value pair. So you have specific keys that holds their corresponding value. So for instance, we have name as our key, and then Shelly as our value that we wanna. If you wanna now output Shelly, then you're gonna need to specify the key that is name. And then we talked about, obviously, that comes in when talking about now accessing a dictionary, accessing values or data in a dictionary, and that will be student name, and then that should output Shelly, obviously, given Shelly is the value that you're looking at. And then talked about the get method. You could also use the get and then the specific key, for instance, for case address, and they should give you the specific value to address key. The in operator is just to check if there's some key in a specific dictionary. And then talked about modifying a dictionary, and then kind of did do this, or also did see this in list reassignment, whereby you specify a key and then provide a new value. And then also at the same time, that should also help in creating new key and corresponding values. And we saw that here too. And then talked about the methods that you need. So for instance, for case.pop method, we talked about .keys method, .values method, and then the .titles method. In terms of how you'd be able to, if you don't want to remove a value, if you don't want to pick specific keys, pick specific values, or even pick specific items. That is both the keys and the values, that is in this case. Now, we did finalize with sets and talked about sets as an ordered collection of unique elements or items. And it uses the curly bracket similar to a dictionary, is that it doesn't have colon to specify the keys and values. So in this case, it's so an example of having duplicate items. So we've duplicated Alice, and then so how we get an output for such, that is. So in that such a, what we saw in that case was like we'll be able to just get, we won't get a duplicate of Alice, we just get one of the Alice values picked. And then so some set operations that you could use, that is add, whereby you don't want to add a value, and then pop should remove a value, and then union should be able to combine two sets together, and then intersection should find common members from both sets, and then the difference should be able to show the values that are only in one of the sets and not the other. And then a bit of accessing values. So again, just reiterating this, but for the most part, you can't use indexing in for accessing members in a set. So in this case, you'd use in operator. And then kind of, so if you do want to use indexing, then go ahead and use change it to a list, and then that's where you can use now the list functionalities to be able to access values. Nice. Now that you know how to store and manage data like a pro, what's next? Well, we're going to see how we can manipulate and work with these data structures in even more powerful ways. This includes using our kind of topics that we're going to learn around, say, branching, looping through values, etc., etc. Now we could go ahead and check out how to access data in a dictionary. So let's see, accessing. Then that means that before we want to access the data, we want to create a dictionary, right? So that would be maybe say student, and then we're gonna use curly brackets. So obviously that means that another pointer to have here is you always use curly brackets, right? And then colon, right? To specify the keys and the value pairs. We're gonna see that. Now, that said, we're gonna have name, and then for case, we're gonna have the name as Shelly, and then now we could specify the age, and then the age would be 24 something, and then now we could specify the subjects, and subjects would be math, and then science, like so. So we could have those as the subjects. And then now, that being our dictionary, you can go ahead and print out student, and that will be our dictionary, the dictionary that we'll be considering. So we can go ahead and have its output, and that will give us, say, the name, Shelly, age 24, and then subjects, math and science. Now, that mentioned, we can now try get to access values. So similar to how we talked about list in terms of accessing members in a list, then yeah, so that's how we'd be able to structure a dictionary too. So by kind of say specify print and then mention student, you're going to provide the specific key name, and then we print that out. So that should give us the value to the specific key, that is our key's name will be Shelly, right? So in this case, it's going to output Shelly in our case. Now at the same time, if you want to access also the other values, so that should look something like this, whereby we can easily change the age, and then obviously it's going to try to check the age key, and then obviously should be able to provide the corresponding value to the age. And then if you run that, then you're going to get age, that is 24. Now also, that means that you can also have this reflected for subjects key. So that will be subjects key, like so. And then in this case, we're going to get our subjects output, right? So we got an error, that is subjects. So we want to understand what the error is. Kind of just tells us key error subjects. So we want to understand what is wrong with the same. So first thing first, we want to check. Okay, yeah, okay. Some kind of simple mistake, that is add an uppercase instead of a lowercase, like so. So if we run this again, we should be able to get our output as maths and science. Awesome. So remember, in this case, what you're seeing is maths science in a list, right? So that means that we have our key, and then we have our values, value as a list, compared to the other one, that is our value is an integer, and then Shelly, that will be our value, which is a string. So if you look at that, then obviously you can always confirm the type of your say data type by having type like so, and then that should tell you like that's a list. If that's a list, then that means that we can do indexing. In this case, we'd be able to have, maybe you can have 0 and then 1 are the indexes, right, for this list that you're considering. And now if you want to pick maths only, then that will look something like this. So let's copy this, have it down here, remove type, and then now just index maths. So that will be a square bracket 0, and then now to run it, we should be able to get our maths as our indexed value. So that's how we'd be able to access data in a dictionary, and then walk through kind of even accessing those data points. Now,